Hello. Well, this is the first of many videos we'll do in this strange spring semester of 2020 with the coronavirus going on. All right, so we've got a WeBWorK assignment due Monday when we come back from spring break, and this is one of the problems in set 12. It's problem 10. Okay, so the question is to find y as a function of x if x squared y double prime plus 5x times y prime minus 21y equals x to the 7th. Okay, so let's think about this. It's a linear differential equation because we only have y prime, y double prime, but it's non-homogeneous because there's this term on the right-hand side with no y's in it at all. It's an initial value problem. And you notice this y of 1 is -6, not y of 0. And we'll see a little bit why later. But how do we solve something like this? Well, step 1 is find the general solution. Okay, and that's going to be y is yh plus yp. I'll talk a little bit, write it down later, but yh is a solution to the associated homogeneous equation at the right-hand side for 0, and yp is one measly solution to the original differential equation, including the x to the 7th. Step 2 is going to be get the two equations and the two unknowns, c1 and c2, that are part of yh. Right, yh has two arbitrary constants in it. So get the two equations for c1 and c2. Step 3 is going to be to solve that system and plug those coefficients back into the general solution. Okay, that's word is, and plug back in is what I wrote. I'm sure you can't read that too well. All right. So I'm going to actually, since you can go back, I'm going to have this technique of erasing frequently because you can always go back and look previously. So let's just go back and think about finding the general solution. Now I really like this problem because it doesn't have constant coefficients. We do so many ODEs with constant coefficients, but this has an x squared times y double prime and an x times y prime. So this has a special property that we can solve this even though it doesn't have constant coefficients. What we're going to do is try y equals x to the r, right? Not y is, say, e to the rx, which is what we've done so much before. If I plug in a power of x to some unknown power, then you notice that when we differentiate, I get something times x to the r minus 1. Differentiate again, I get something times x to the r minus 2, and these factors will just compensate. So let's just do that. We get y prime is rx to the r minus 1, and y double prime is r times r minus 1, x to the r minus 2. Right? So if I do x times y prime, we get r times x to the r, because x times x to the r minus 1 is just back x to the r, and x squared y double prime is r times r minus 1, x to the r again. So if I plug this type of function, y is x to the r, into the left-hand side, I get some mess times x to the r. Okay, so you plug this guess into Ly equals 0. Okay. So I'm trying to find yh now. To find yh, we do this. So let's actually simplify what L on x to the r is. L x to the r. L is this whole left-hand side, right? So this is Ly is that left-hand side. So L acting on x to the r is, well, if I get r times r minus 1 times x to the r. That comes from this. That's x squared y double prime. And then I add 5 times xy prime. Xy prime is r x to the r. And then I take minus 21 times x to the r. We should probably simplify this because we're going to use this a lot. I get r squared. Basically, it's something times x to the r. What's the something? I get r squared times x to the r. I get minus r times x to the r, but I get a plus a 5 over here. So that gives you a plus 4r. And then I get minus 21 all times x to the r. And that's going to be a useful thing. All right. So what we're going to do is we want that to be 0 for all x. All right, we're going to solve Ly equals 0. Okay, so we get the thing that's like the characteristic equation. We get x to the r is a solution to Ly equals 0 if r squared plus 4r minus 21 equals 0. And hopefully it factors. If it doesn't, check your algebra. We can factor this. Okay, 21 is 7 times 3. 4 is 7 minus 3. Good. So I get a minus 3 and a plus 7. Good, right? So that means the two solutions are R1 is 3 and R2 is negative 7. Okay? So the general solution to the general solution to Ly equals 0 is what we call YH. The homogeneous solution is C1 x to the 3 plus C2 x to the minus 7. All right? And now we ask these two arbitrary constants. And now we want to find one particular solution. Well, try yp is a times x to the 7th. Why x to the 7th? Because the right-hand side is x to the 7th. We don't know what that a is going to be. That's like the undetermined coefficient that we had before. We try that in Lyp is x to the 7th. Well, we've actually done a lot of the work. L acting on ax to the 7th is a times that whole left-hand side acting on x to the 7th. But we've already done that. It's going to be, in fact, let's use this factored form. It's 7, well, maybe I shouldn't do that too much. It's going to be a times, what happens when I put in r equals 7? Okay, I get 7 minus 3 times 7 plus 7 x to the 7th, right? I'm using this form of that r squared, right? So what is this? This is equal to a times 4 times 14 x to the 7th, and I'm going to set that equal to x to the 7th. Right? Cool. So that's pretty easy to think. See, we get a is 1 over 4 times 14, or 1 over, I don't know, 7 times 8, which is 56. Right? All right. So we're basically done with this step 1. We found p plus yh. So the general solution is yh c1 x cubed plus c2 x to the minus 7 plus yp, which is plus 1 over 56 x to the 7th. Right? And we're done with step 1. It would be kind of nice if we could, kind of nice if we could just ask you to do this, because it's going to get a little bit messier from now on. But that's not what the question asks. All right, so now we want to start step 2. You notice that this is where it comes in. Evaluating all of these powers of x at x equals 1 is simple, right? 1 to the 3 is 1. 1 to the minus 7 is 1, right? So if I had to evaluate this at like x equals 2, I'd get really gross numbers. But even worse, if I wanted to evaluate this at x equals 0, I would have 0 to the minus 7 undefined. Bam! Can't divide by 0. All right. So step 2, going to impose these initial conditions and find 2 equations and 2 unknowns of C1 and C2. Let's start with the derivative. Y prime is going to be 3C1 x to the 2th minus 7C2 x to the minus 8. Okay, plus 7 over 56 x to the 6th. All right. So you notice that this thing here, 56 is 7 times 8, right? So this is equal to 1 over 8. That will be useful. All right. So remember, we got to differentiate and then set equal to 0. Okay. All right. So what are the 2 initial conditions? Y of 1, using our general solution, is C1 plus C2, and I'm using the fact that 1 raised to any power is 1. Okay, plus 1 over 56. I'm going to set that equal to negative 6, right? And I get y prime of 1, which is 3c1 minus 7c2 plus 1/8. I'm going to set that equal to negative 4. Okay? All right. So now I think I'm ready to summarize step 2. I'm almost done here. Step 2 is I'm to find the 2 equations and the 2 unknowns, C1 and C2. And that's going to be C1 plus C2 is negative 6 minus 1 over 56. Let's write that so you can read it. And 3C1 minus 7C2 is equal to minus 4 minus an 8th. Let's circle that. I'll circle this too. These are the results of step 1 and step 2. All right, so now we're going to go to step 3, which is find C1 and C2, and then plug them back in. Now, in some easy problems, we expect you to do this by hand, but it's really gross. So actually, I did this on my calculator. I just defined A on my calculator to be the augmented matrix for this system, which is 1, 1, negative 6 minus 1 over 56, and 3, negative 7, negative 4 minus 1/8. And remember, when we write it as an augmented system, we sometimes put this down here, okay? I would also think it's fine if you can solve this by any method you have on the computer, because it's too gross to solve by hand, really. So I put this in, to find this on my calculator, and I just actually entered this entry by writing in minus 6 minus 1 over 56. Enter, went to the next thing, okay? But then what you want to do is, I found the reduced row echelon form of A, using a calculator again, and I converted that to a fraction. And that turns out to be, I have it written down here, what was it? 1. Okay, the first part's a 1, 0, 0, 1, and I get After converting to a fraction, I get minus 37 over 8. And then the next one, when I C2, is minus 39 over 28. Wow. So what this is really saying is, this system is equivalent to a new system that basically says that C1 plus 0 times C2 is negative 37 over 8. And 0 times C1 plus C2, or 1 times C2, is minus 39 over 28. Okay? Cool. So that means we're ready. That's a lot of work, especially did it by hand, but we're ready to do step 3. Step 3 says just plug in these two numbers into this general solution. And step 3 says, results of step 3 is that the solution to the initial value problem is y equals, well, c1 times x cubed minus 37 over 8 x cubed plus c2 times x to the minus 7, c2 is negative again, minus 39 over 28 times x to the minus 7 plus 1 over 56 times x to the plus 7. Okay, so that I did enter that into WeBWorK and got the green flash, so that was really cool, felt good. Let's think a little bit about this too. This solution is only defined for x positive because it can't cross x equals 0 because of that term. So this solution is defined for x positive. Okay? The solution to the initial value problem where I put in the initial conditions at x equals 1. All right. Well, so as all the YouTube celebrities say, be sure to click like or whatever, subscribe to my channel. I doubt you really want to do that. But anyway, so this is the first of what might be many videos kind of like that. Give me feedback. Is this way too long? Is it way too boring? Well, I don't know if we can really fix that, the boring part, but maybe the long part, I can break things up into smaller bits. A few things about this problem is it's a gross problem with the numbers, right? On the test, these numbers would all be much, much more kind. The coefficients here would be probably integers. Anyway, I think it's a really great example to show that we can use y as yh plus yp, a homogeneous solution plus particular, in a case that's different from our linear homogeneous ODEs with constant coefficients or the linear non-homogeneous ODEs with constant coefficients. We have so much of that y is x to the r, y is e to the rx. To do that so much, it's nice to have something a little bit different for a change. All right, bye.